Dark matter mystery solved. Scientists believe that mirror universe running backwards in time could hold the key. Our universe may have a mirror, an anti-universe counterpart, which is running backwards in time from the Big Bang. That would solve the mystery of the cosmos missing dark matter. Physicists have claimed they're coming up with all types of hypotheses. Physicists have determined that the laws of nature tend to follow three fundamental symmetries: that of change, parity, and time, known collectively as CPT symmetry. What it means in theory is that if you were to consider the interactions between any particles, you could reverse the charges, switch matter with antimatter, for example, replace every particle, interaction, and decay with its mirror image, a so-called parity transformation, or run the interaction backwards instead of forwards in time, and it would still behave the same way. In reality, however, things are a little more complicated, as sometimes individual symmetries are not followed, and what physicists call is a violation. If we take neutrinos, for example, subatomic particles that are similar to electrons but with no electrical charge and a minimal mass, they're thought to always spin clockwise relative to the direction which they are traveling. And physicists call this left-handedness. If you hold out your hand with your thumb pointing towards you and your fingers bent, you'll see that your fingers curl around the thumb axis in a clockwise direction. Because all known neutrinos are left-handed, you can't perform a parity transformation on them, as a mirror image would be a right-handed neutrino, which does not seem to exist. And similarly, as antineutrinos are always right-handed, you can't perform a charge transformation on a neutrino, as you would have to end up with left-handed antineutrinos. While individual symmetries have been seen to be violated, no system has ever violated all three parts of CTP symmetry at once. It appears to be fundamental. In their study, Dr. Latham Boyle and his colleagues at the Perimeter Institute for Theoretical Physics in Waterloo, Canada, propose extending the scope of CTP symmetry. They set out to explore whether it might apply not just to basic interactions within the universe, but also to the very universe itself. And according to the trio, the starting point of this thought experiment came from a simple observation that in the hot radiation dominated era of the early universe that began less than a minute after the Big Bang, the maths describing the background universe has time reversal symmetry. They said, we interpret this as a clue that the state of the universe, hence the space-time itself, as well as the quantum state of quantum field theory on that space-time, might actually respect CPT symmetry. The cosmos as we know it evolves forward in time. For CPT symmetry to apply to the universe, therefore, it stands to reason that our understanding of the universe can only be half of the picture. There must be another universe lying on the other side of the Big Bang, one in which time runs in the opposite direction, they said. In this mirror universe, all the particles would have the opposite charge to the prime universe counterparts, appearing as if flipped in a mirror and run from our perspective backwards in time. While on their own, both our mirror image violate CTP systems, when taken together as a pair, they would obey it. And the team said the universe before the Big Bang and the universe after the Big Bang may be viewed as a universe-anti-universe pair, emerging directly into the hot radiation-dominated era we observed in our past. And considering our known cosmos as part of the universe-anti-universe pair has some interesting ramifications for our understanding of physics. To start with, the CPT respecting universe would naturally expand and fill itself with particles, the researchers said. This absolves the need for the so-called inflationary epoch, in which the universe rapidly expanded for a fraction of a second shortly after the Big Bang, increasing its volume by a factor of a tredecillion, or 1 followed by 78 zeros. There is a lot of evidence to suggest an inflationary event did occur. The models for such all have inherent vagaries, and other interpretations may still be viable. At the same time, a universe that respects CTP, we need to have one massless species of neutrino as well as at least one right-handed variety of neutrino, which, as noted earlier, have never been observed. and if they do happen to exist, right-handed neutrinos, physicists believe, would be abundant but largely undetectable and interact with other particles solely via gravity. This makes right-handed neutrinos an intriguing candidate for dark matter, the mysterious component of the universe whose existence and gravitational influence is needed to fully explain the motion of stars within the galaxies. Physicists have estimated that around 27% of the universe may be composed of dark matter. And unlike in Star Trek franchise, where access to the mirror universe and its proliferation of sinister-looking goatees is but a transporter malfunction away, we will likely never be able to visit or even directly measure our anti-universe counterpart. But researchers explain there are ways that we could infer the existence of a real-life mirror universe by studying the properties of our own cosmos. So this is another theory, of course. This is by Ian Randall, Express UK. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.